Good afternoon, ma'am and sir. This video is made as final presentation for the complete work I have done in my BTech project 2 this semester. The problem statement is to build a state-of-the-art model to detect formality level of text. For that, first I have explored a few research papers to get an intuition about formality and previous works in formality. One of the paper is an empirical analysis of formality in online communication. In this previous literature work says there is no generally agreed upon definition as what constitutes formal language. Some define formality in terms of situational factors such as social distance and shared knowledge. Uh, Much prior work on detecting formality has focused on the lexical level of formality. Existing statistical approaches use treat formality as a binary classification task, uh, relied heavily on word lists to differentiate the two classes. Uh, to understand the human perceptions of formality in this work, the authors do not attempt to develop a concrete definition of formality, but instead they take a bottom-up approach in which they assume that each individual has their own definition of formality. For further experiments, they have taken four genres of data: news, blogs, emails, and community forums. Uh, they To understand the factors affecting the formality and the features uh, to extract from the text to understand formality. From this paper, like from the experiments they have done, they have detected that engram is the best feature to detect formality. Most of the previous works in formality consist of traditional and conventional models. So, for enhancement in the formality classification, we have explored state-of-the-art models in NLP such as BERT-based models, and finally ensembling BERT-based models to further enhance the performance. So, for our experiments, we have employed the GYAFC dataset, which is a benchmark dataset in formality detection. It mainly consists of two genres: entertainment and music, family and relationships. Each of the genre consists of 110,000 formal informal sentence pairs. Uh, for our experiments I have merged both of the data sets to get training instances of 200,000 training instances, 10,000 tuning instances, and approximately 5,000 testing instances. And I have experimented with mainly four state-of-the-art models, namely BERT, Roberta, Electra, and DBERTA. I have also tested on XLNet, but Collab normal version cannot handle it as it is too large. So, uh, as you can see on the screen, the performance of the baseline models I have worked on is here. The best performing baseline is Roberta with 93.98 performance, and the least performance is BERT 89.56. After testing with the baseline models, I have tried ensembling the models. These are the different types of combinations I have tested uh, using the ensembling techniques. The best performing, and as you can see from the performance, ensemble models perform a lot better than uh, I cannot say lot, but yeah, ensemble models perform better than the normal models. The best performing ensemble is Roberta plus Electra with 94.906 as its performance, and the second best is Roberta plus BERT, which is 94.72. Uh, so after trying the ensembling models, I have also explored hyperbolic embeddings. Hyperbolic embeddings, like learning representations of symbolic data such as text, graphs, and multi-relation data, is important to understand text data. So, uh, so typically the objective of embedding methods is to organize symbolic objects in a way such that their similarity in embedding space reflects their semantic and functional similarity. For this purpose, we have already uh, researchers have already developed uh, models like word to vector, glove, and fast text. But the the these are succeeded in many instances, but but the fundamental limitation is their ability to model complex patterns, which is inherently bounded by the dimensionality of embedding space. Uh, so, so there is no method yet exists that is able to compute embeddings of large graph structured data such as social networks, knowledge graphs, and taxonomies. So, for that purpose, in this work, the authors, the authors want to mitigate the problem for a certain class of symbolic data, that is large datasets whose objects can be organized according to latent hierarchy. So to exploit this structural property for learning more efficient representations, they proposed embeddings not in Euclidean space but in hyperbolic space, that is a space with constant negative curvature. Uh, we can imagine hyperbolic space as a continuous version of trees, like as shown in this figure. So uh, the authors in this paper opted for point care point care model to train the embeddings. Uh, so I have experimented with point care glove model. We already know glove embeddings, right? So glove embeddings trained on point care model. I have used those embeddings to uh, for the GYAFC dataset. I have developed a artificial neural network which consists of embedding layer, dropout layer, batch normalization layer, convolution layer. It's a hybrid neural network. I have developed this neural network and I have used the embeddings, point care embeddings, but the performance is not as good as the ensemble models. So yeah, this is the work I have done till now in the BTech project too, where I have also we are also writing a research paper on the work we have done. Uh, this is the research paper which is currently under. We are currently writing the paper. Uh, this is an amazing project. I feel it has a lot of scope in the future also. Thank you, thank you for giving me this opportunity.